Hey guys, Dev Party here, and today I'll be showing off the Raycaster that I made. If you don't know what a Raycaster is, it's the rendering technique used in games like Doom 1 and Wolfenstein 3D. Wait, what? You still don't understand? Fine. I guess I'll just have to show you what it is. So basically how a Raycaster works is you have a player and he's in a scene, and then you also want some walls in the scene, and you want the player to be able to see these walls. So you just have a couple of walls. I'm just going to draw 4, right? And then the player has an X position and a Y position, and the player is at this X position, this Y position. It also has one other variable, which is its direction, and then you just kind of draw its direction right here, like that. And then with its direction, you kind of cast some rays out of it, which is why it's called a ray casting. And then with these rays, you're actually going to measure the distance. If there's a collision, you measure the distance between the collision and the ray. So for instance, this ray right here, we have a collision right here, so we measure the distance between the player position, which is right here, and the ray intersection, which let's just say that's like 4 or something, and then you do this for every other ray like that. And then this one would be infinity, right? And this one maybe be a little bit smaller than all the other ones. And then what you do with this information is, since it's left to right, you have a screen over here, and by using this information, we can inverse it with the screen positions, which is like a map function. And then you kind of draw it inverse proportional to the distance, which the bigger the distance is, the smaller it will be, kind of like this, right? And then if it's infinity, you draw nothing. And then if it's really like small distance, like 3, you draw this. Now let me just cast out like a couple more rays like this. You can see right here, we're going to cast out some more rays. And then we're gonna see this wall even better, right? Because we can see its distance is from the player. And then these 2 rays don't hit anything. So you can kind of see that it looks like this wall lines up like a wall, right? And then this bound would line up like a wall. Like, let's cast another ray in between. This isn't really how it worked, but if you cast another ray there, you can kind of see some walls forming, right? Now this is the basics behind raycasting, so let me go ahead and show you the code. So here's the code, and basically it's a chunky boy. There's a lot of code here, so let's start from the bottom. Let's take a look at the renderer that I made. So the renderer has a couple of basic functions, but the player is only actually going to use 2 of them, or more likely the developer. As you can see, you have actually 3, I guess, technically. You have a create window function that allows you to create a window with some size and a resolution, which we'll get to later, and an FOV, which we'll also get to later. And then there's also a draw function, which the player or the user somehow needs to call in an update function. I don't know why I keep saying player, it's technically the developer. The developer uses that in the update function, right? And then there's only one other thing that the developer is going to use, and it's this add function, and you can see it in use in the main.js over here. You say render.add, and then you have some bounds with maybe some positions and materials. Now let's get to the bounds and stuff. So the bound has some basic stuff. It has its first position and its second position, which you can see being set here. And then it has a default material, which is just white. And you can see it has surface normals, and it has types, and it will recalculate the normals in the start. We're going to skip over sprites. This is still in development. And then we have array, which is pretty much the core. This is how everything works. What we do is we have a position for the ray, and we have a direction for the ray, right? And then to actually cast the ray, we call this cast function on the ray, and then we cast it to the wall. And I'll show you how we actually cast to all the walls in a second. So basically what we have is we set these positions here, and then I have this math.line function that I defined up here at the top, as you can see right here, because I don't just want it to mean the cast thing, because I'm going to be using it for other things too. So we have this, and we're basically returning the point at the collision, if there is a collision. If not, it just returns false. So let's go up and see how we actually render all this. Now, what we do is we cast rays out of every angle on the screen, depending on the resolution. So let's say your screen is like 1,600 pixels wide, right? If your resolution is 4, you're actually only going to have 400 different bars, which makes it a lot easier to render. And that's actually what it defaults to, 1600 in width and 4 resolution. And then we have a min dist variable, which is automatically set to something so high that it wouldn't even render at all. And then what we do is we cast out enough rays for every object at every point so we can get the minimum distance, and then we get the color of the object that we hit. And we will render this ray after normalizing the distance. So there's two functions we need to look at now, the render ray and the normalized distance. Normalized distance isn't that fun. We just kind of do some math to make it not bulge and stuff. I'll show you what that looks like in a minute. And then the rendering of the ray is the interesting stuff. We kind of have to invert the height like I was talking about in the explanation. And we have to get some like render fog so it doesn't look terrible and doesn't just cut out. And then we just render a rectangle. Alright, now let's go ahead and take a look at the actual Raycaster. So this is the Raycaster in action, and I think after all that work, it is actually doing pretty well. I think there's some other things I could add, like a ground maybe and a roof, but you know, those are for other days. I will also probably add layering, so you can add different layers of things, maybe jumping with the player. There's a bunch of stuff I want to do, but for this video, this is about as good as it's gonna get. Sorry about that. There isn't even any collision yet. Oopsie. But you can see the distance fog and work, and everything's looking pretty nice except for this weird fisheye effect right here. I'm not sure what's going on with that, but it's okay. And you can clearly see that it is a Raycaster if I go ahead and put myself up to a wall like this. You can see that those are definitely rays hitting. We can even change the resolution. So if we go render dot set res, I'm going to set it to 50 so we can really see. Yeah, this is definitely a Raycaster. Alright, thank you guys for watching. If you like content like this, please leave a like and subscribe. I'll see you all next time. Bye.